translative motion of center of mass plus, I think I can make it big, no? Y2. Rotative motion about center of mass. Let's substitute all. Due to translative motion, it is mv naught r. About what point? About point P. About axis passing through point P and perpendicular to the plane. This should be equal to clockwise. Then I see 2 omega naught. How it is? Anti-clockwise. This is very important. Check it now. I'll help you with arrows also. No, after this. mv naught r. It's a ring. Put mr square 2 omega naught. Let's solve further. And numerically what happens, where all you want, you can apply this if you want to replace mv naught r. This is clockwise, so this will be here. Let me replace v naught here. So v naught, what I can write it as r omega naught. Tell me which will be greater, clockwise or anti-clockwise spin. Black color one is clockwise, red color is anti-clockwise. So let me take let me make, this is negative in this case. This will be m r square omega naught. So net what I'm getting, check it, initial angular momentum, what we are getting. The initial angular momentum what we are getting is anti-clockwise. So finally what happens, the rigid body will attain pure rolling with angular momentum will be, resultant angular momentum will be anti-clockwise, counterclockwise. Okay, let's come for the direction of friction. So what is the velocity of point P? Again it is towards right only. Forward slipping, where which is equal to V naught plus R to omega naught. So the friction, how it will act? Backward. This friction acting, what will do? It will retard and it will set up an anti-torque. Now, what will decrease first? What will become zero? 2 omega naught or V naught? According to this condition, the rigid body should attain pure rolling with angular momentum. How it should be? Anti-clockwise. I don't have space, so I had to show. I'll show it below. First, what will happen to the ring? Oh. See, completely visible, all things. What will happen to ring? The friction will decrease velocity of center of mass. It will also decrease the angular velocity of this. So after 1 instant, we'll get like this. So this will be the velocity v1, angular velocity omega 1. And I'll come and check it. Again, the velocity of point P will be towards right and the friction will be acting backward. I agree this, and still what it is, forward slipping. Now also forward slipping. Then the friction acting is such that the body, rigid body, will come to rest. Sir, how do you can say? Center of mass will come to rest. But it will have still some angular velocity. Is it justified? Yes, you see that. It must have angular momentum anti-clockwise at all. Any instant net angular momentum should be this one. So can we calculate this omega 2? Yes, we can calculate. What is there in this one? T equals 0, this is at some time. You write it. T naught or select it T2. And now again come and check it. Velocity of point P will be still towards right on. Velocity, so how it is possible, sir? Center of mass at rest and point P moving. This is tangential velocity. This point will have tangential, so the friction will act like this. So this friction acting, what it does now, will make the center of mass to accelerate towards left. So what it does is like it will make the center of mass to accelerate towards left. Velocity of Vp3, I'll write it. This will be V3. And this friction acting, how the friction will act. Friction will act in this direction. Vp3. So here look at this velocity of point P2 like this. So still what will happen? The friction will, oh, wait, it's some. You can ask question like, sir, why you are showing Vp3 still backward only? Because V3 is there now. Still V3 will be less than or omega 3. What about your V1? Anyway, there's no question of Vp will be towards left here. This is very important. What is this? Still will be backward slipping only, no? Now shall I call backward slipping or forward slipping? It will be backward slipping. Now what this friction will do, it will keep on increase the linear velocity, decreases angular velocity. It will set up a torque. You can see that one. It will be like this. And it will accelerate center of mass. Then finally at one point, it will attain pure rolling. Where did it attain pure rolling? Exactly at the initial position that we have to calculate. It will attain pure rolling. This is a rough surface. This you keep in mind. So finally it attained the pure rolling like this. So pure rolling means Vp equal to 0. I want this V and omega, how to calculate. There's a basic necessity condition. If it were pure rolling, it would happen that much. Since not a pure rolling, V naught is less than 2R omega naught. Now how to calculate this V and what is the time taken? Finally it will time t, how to determine this? It's quite very simple. We'll go for final angular momentum. Final angular momentum, MVR plus IC omega. About point P apply, both are anti-clockwise. Both are positive. So this is mr square into omega. For pure rolling, so what we can write it as, omega I can write it as to MRV. Now, from conservation of angular momentum, LPZF should be equal to LPZI. So 2mv is equal to mr square omega naught. I brought it, no? Or we can also write it as m r v naught. Either of things. Now I'll do one thing. So let me substitute in order. Mr square omega naught, no? So 2mv mr into r omega naught. So this will become how much? 2 mv mr into v naught. Once again, where all, if you can do this replacement. Can we calculate the time taken? Okay, there's everything about. So what's happening? This you can take better. You take bangle. If it is some plastic or something, you press it and push it. No, negative spin. So how the motion of this? It will be like this. Huh? It will go and again it will return back. So now how to calculate the time taken? I'll take help of the equations of motion. V is equal to V naught plus AT. Look at the final velocity, opposite initial velocity. And look at the retardation, AC. AC is, sir, how you can say, go back to equation of motion. The sign for AC and V Wattman should be opposite to initial velocity. Look at AC now. But sir, it is first AC is towards left. After AC Wattman will increase velocity. I think the equations of motion from that AC should be negative only. And we know what is V naught. V is V naught by 2. And AC is what? Mu GT. After this much of time, it will attain pure rolling. Now, can we calculate the total distance covered? I don't know. Please look at the point P. Who will determine forward or backward slipping? The forward or backward slipping, the velocity of point P, not like V naught or 2 omega naught or that one. Look at the velocity of point P. It is towards right. It is towards right, no? So what is this? Forward slipping. If the velocity of point P in the direction of velocity of center of mass, forward slipping. If the velocity of point P opposite to velocity of center of mass, then it should be backward slipping. I think that's a basic idea. If the velocity of point P, so here what velocity of point P in the direction of velocity of center, it's a forward slipping. Backward slipping, I think, here. Okay, we don't have anywhere. Backward slipping. Yeah. If the velocity of point P is opposite to velocity of center, I think I have one problem. Yeah. If the velocity of point P opposite to velocity of center of mass, backward slipping. Not like V naught greater than less than. From the lowest point is what we should bring. Now, what is the total distance covered? How much of distance it has moved to attain pure rolling? So first, how the path of that? It will move towards right, this one. So overall path, the path, it happens of this kind. First, how the path of this will be? It will go like this, comes to rest, then it will attain pure rolling somewhere here. So here it was having a velocity V naught, retardation mu g, and it has come to rest. And finally it will attain pure rolling, where mu g will be like this. Time taken to move from here to here is what you can call like a TA. Time taken to move from here to here, you can call TB. I think we wrote T2 or T3 something. T3, let me call this is T4. Total time taken will be T. This is T equal to 0. So here it has come to rest and again it started moving. So we know total time. So what we need the distance covered. This will be x1. This will be x2. Total distance covered x1 plus x2. So do we know T3? Yes, T3 also we can get it. V naught minus mu g T3. So how to calculate the distance covered? It should be V naught square by 2 mu g. How to get the distance covered by this? V square by 2 mu g. Instead of times, now I'm using. So if you want that time, you can also calculate the time. Already we know time. Total time is T3 plus T4. This is the total distance covered by to attain pure rolling. Check it now. Is it equal? Means will it attain pure rolling? Again, it's the initial point only, here only. Now if check this, if this distance is equal to this one, means if x1 equal to x2, it will attain pure rolling at its initial point only. If x1 greater than x2, before reaching its initial point, it will attain pure rolling. They may ask you all these things. Total distance covered to attain pure rolling. So what is the rigid body? First, it will move like this, no? Then it come back here. So let attain pure rolling